There are moments in the vast theater of the cosmos when a single frame of light pierces the darkness, not just illuminating stars or swirling galaxies, but whispering secrets from realms we can scarcely comprehend. Imagine a pinpoint of infrared glow, captured in the chill of space a million miles from Earth, revealing not a rock tumbling blindly through the void, but a frozen emissary from another sun, bearing molecules etched by the birth pangs of a distant world. This is no ordinary snapshot. It's the James Webb Space Telescope's first true gaze upon 3I/ATLAS, the third confirmed interstellar wanderer to grace our solar system. And in its crystalline depths lies a story that stirs the soul. A reminder that we are not alone in the universe's grand migration, that the building blocks of life, of worlds, drift eternally between stars, connecting us to origins beyond our wildest dreams. What Webb has unveiled challenges not our fears, but our humility, inviting us to wonder at the fragile threads binding existence itself. Join me as we trace this cosmic traveler's path, from its silent arrival to the revelations that could redefine how we see our place among the stars. In the pre-dawn hush of July 1st, 2025, high in the arid peaks of Rio Hurtado, Chile, the asteroid terrestrial impact last alert system, Atlas, NASA's vigilant sentinel against cosmic threats, scanned the southern sky with mechanical precision. Its robotic eye, one of four scattered across the globe from Hawaii to South Africa, sifted through the faint smudges of starlight and shadow. There, amid the dense backdrop of the galactic center's stellar haze, it locked onto an anomaly, a faint, fast-moving speck, hurtling at over 137,000 miles per hour, far too swift to be lassoed by our sun's gravity. Preliminary data trickled in, archived observations from as early as June 14th, confirming its hyperbolic arc, a parabolic escape route that screamed interloper. By July 2nd, the Minor Planet Center had christened it 3I/ATLAS, the I for interstellar, the third after Oumuamua's enigmatic cigar in 2017 and Borisov's verdant tail in 2019. At discovery, it lounged some 410 million miles from the Sun within Jupiter's orbital embrace, a rogue the size of a small mountain, perhaps 3.5 miles across according to Hubble's later gaze on July 21. No immediate alarm bells rang. Interstellar visitors, rare as they are, pose no peril. Yet in the quiet control rooms of observatories worldwide, a subtle thrill stirred. This was no mere asteroid, as initial glimpses suggested. Follow-up from Chile's Deep Random Survey and Arizona's Lowell Discovery Telescope revealed a whisper of a coma, a hazy envelope of gas and dust, and a tentative tail, 3 arcseconds long, betraying its cometary soul. 3I/ATLAS wasn't crashing through. It was awakening, stirred by the distant warmth of our star. As word spread through astronomical networks like ripples on a still pond, the global chorus of telescopes turned skyward, their lenses hungry for more. The European Southern Observatory's fleet in Chile and Australia's telescopes joined the fray, while in Hawaii, the Canada-France-Hawaii telescope teased out spectral hints of its composition. Early spectra painted a portrait of an ancient relic, rich in carbon dioxide, that frozen dry ice suggesting formation in the frigid outer reaches of its home system. Billions of years ago, perhaps amid the thick disk of the Milky Way, where stars older than our own flicker like embers. Unlike Oumuamua's barren silence or Borisov's carbon monoxide blush, 3I/ATLAS hinted at water. Vapor detected faintly by NASA's Neil Gehrels Swift Observatory in ultraviolet glimpses from July and August, glowing with hydroxyl signatures at distances where direct sublimation seemed improbable. According to preliminary findings from Swift's UVOT instrument, this outgassing stemmed not from surface melt but from tiny ice-coated dust grains lofted into the coma, a process that evokes the delicate alchemy of comets as they dance with sunlight. Emotional undercurrents ran deep in these first reports. Astronomers, long starved of such pristine samples from beyond, felt the weight of history. It's like holding a fossil from another epoch, one ESA researcher confided in a preprint abstract, her words laced with awe. This comet, ejected perhaps by a giant planet's gravitational shove or a neighboring star's nudge, had wandered interstellar space for eons, potentially 7 billion years, predating our solar system's fiery dawn, carrying unaltered clues to planetary nurseries we may never visit. By mid-July, the Vera C. Rubin Observatory's serendipitous captures from late June showed a subtle swelling in its coma, a nucleus diameter constrained to under 5 kilometers, fueling speculation. Had Atlas missed it earlier only because of the galaxy's crowded veil, or was this visitor deliberately veiled until now? The true drama ignited on August 6, 2025, when the James Webb Space Telescope, perched at Lagrange Point 2 like a golden eye gazing into eternity, swiveled its 6.5-meter mirror toward the intruder. Webb's near-infrared spectrograph, NIRSPEC, a marvel of cryogenic engineering cooled to minus 266 degrees Fahrenheit, pierced the infrared veil where heat signatures bloom invisible to human eyes. The resulting image, 3 panels of ethereal glow, a brilliant white core fading to crimson, tangerine, and sapphire blues, emerged not as a leak or rumor, but as NASA's proudly unveiled gift to science. At 470 million kilometers from the sun, 3I/ATLAS's coma dominated the frame, a diffuse halo some 10,000 kilometers wide, laced with spectral lines that screamed abundance. Carbon dioxide in ratios unprecedented among known comets, dwarfing water's presence by factors of 2 to 1, water ice crystals glinting like cosmic snowflakes, traces of carbon monoxide and the pungent carbonyl sulfide, evoking rotten eggs in the void. The highest CO2 to H2O ratio we've ever measured, the research team noted in their August preprint, a finding that implies relentless radiation bombardment in its youth, sculpting a chemistry alien to our Oort cloud kin. Webb's data, cross-referenced with Hubble's visible light portrait in SPHERE's all-sky infrared sweep from August 7 to 15th, refined the nucleus to a compact 1 to 3.5 kilometers, its surface a mosaic of refractory dust and volatiles held in precarious balance. The emotional resonance hit like a solar flare. Here was tangible proof of diversity in exoplanetary systems, a frozen time capsule suggesting that water-rich worlds, and perhaps life, might be the norm, not the exception, across the galaxy. As lead analyst Marco Micheli from ESA's Near-Earth Object Coordination Center reflected, aligning Webb's pinpoint field of view had been quite challenging, yet the reward was profound, a glimpse into the primordial soup from which Earth drew its oceans. In that infrared hush, 3I/ATLAS ceased to be a speck. It became a bridge, evoking a quiet reverence for the universe's shared heritage. Yet beneath the scientific elation simmered unanswered riddles, pulling at the threads of our understanding like gravity's inexorable tug. Why, at 7 astronomical units from the sun, nearly 3 times Earth's distance, did SWIFT detect substantial water outgassing, where temperatures hover at a frigid minus 200 degrees Celsius? Traditional models predict sublimation only within 2.5 astronomical units. Yet here were hydroxyl emissions, faint but insistent, traced to micron-sized grains ejecting ice pockets into the coma. This activity is attributed to the release of small, ice-coated dust particles, NASA's analysis posited, a mechanism that echoes lab simulations of porous regoliths, but demands rethinking cometary longevity. Preliminary findings from ground-based Gemini South in Chile, capturing a broad coma and 24 arc-minute tail by late September, showed the dust reflecting sunlight with unusual efficiency, its particles micron-fine, scattering blue light into a subtle azure tint. A greenish hue reported by amateur networks, though Webb's infrared dismissed exotic organics as culprits. Speculation swirled. Had 3I/ATLAS's long voyage through cosmic rays stripped its volatiles, leaving a resilient crust that fractures unpredictably? Or does its origin in a radiation-bathed disk explain the CO2 dominance, a marker of formation beyond the water's snowline in a system unlike our own? These questions tugged at the heartstrings of researchers, many of whom confessed in interviews a profound sense of connection. It's as if this comet chose us. one Hubble collaborator mused, her voice cracking with the weight of isolation lifted. By October 3rd, as ESA's Mars Express and ExoMars Trace Gas Orbiter, TGO, pivoted for their close encounter, the comet brushing within 1.5 million kilometers of the red planet, data from Omega and Nomad spectrometers hinted at faint spectral matches to Martian volatiles, a tantalizing overlap that stirred visions of shared cosmic deliveries. JWST, en route to Jupiter's icy moons, would soon join, its particle sensors probing for ejected grains, amplifying the urgency. This visitor's flyby was fleeting, its secrets ephemeral. October 3rd, 2025, dawned with a cosmic intimacy few could have foreseen. Over Mars' rust-red horizon, 3I/ATLAS loomed like a spectral ghost, its trajectory slinging it past at 68 kilometers per second, 42 miles per second relative to the Sun at perihelion later that month. ESA's Mars missions, veterans of dusty plains and methane hunts, captured what TGO's Nomad dubbed the closest view yet of an interstellar guest. A coma swollen to 20,000 kilometers, its tail streaming anti-sunward in elegant defiance of solar wind, laced with sodium and iron spikes from vaporized crust. SPECAM and Omega spectrometers drank in the light, revealing water vapor plumes mirroring those on Phobos' surface. Ice grains lofted high, perhaps seeding the thin atmosphere with exogenous whispers. Hints of volatile activity beyond our system's norm, the preliminary readout beamed back, evoking a pang of vulnerability. Mars, scarred and silent, now a reluctant host to a stranger's breath. Ground telescopes worldwide echoed the spectacle. Chile's Very Large Telescope arrayed spectra showing pulsed outgassing synced to the comet's estimated 8-hour rotation. Thermal spikes of 20 Kelvin, suggesting subsurface pockets venting in rhythm. Emotional peaks crested here, in the raw data feeds watched live by global teams. Gasps in control rooms as hydroxyl lines sharpened. Tears from veterans who chased Oumuamua's shadow in vain. This was revelation incarnate, 3I/ATLAS, with its CO2 cloak and water whispers, challenged the isolation of our solar bubble, implying that life's ingredients migrate freely, perhaps sprinkling barren worlds with potential. Yet a shadow loomed as perihelion neared on October 20th. Models predicted tidal stresses peaking, the nucleus, fragile after billions of years, risking fracture. Would it endure or shatter like so many sun grazers before? The weight gnawed, a cliffhanger etched in starlight. The crescendo arrived not in explosion, but in quiet transformation, a reveal that twisted awe into introspection. On October 15, as 3I/ATLAS crested within 1.2 astronomical units of the Sun, NASA's SPHEREX, launched mere months prior to map the universe's icy epochs, swept its spectrophotometer across the comet's flank. The data, fused with Webb's August baseline, unveiled the surprising heart. Not just CO2's dominance, but a deficit of complex organics, a pristine simplicity suggesting ejection early in its system's violent youth, before heavy bombardment could infuse it with life's precursors. Too clean for comfort, quipped a preprint co-author, her tone laced with the thrill of anomaly. Carbonyl sulfide's presence, OCS, a prebiotic molecule, hinted at sulfur cycles akin to early Earth's, while carbon monoxide's trace evoked volcanic outgassings from exomoons we can only model. Emotional undercurrents swelled. In virtual seminars, astronomers shared stories of lost colleagues who dreamed of such samples, the comet a surrogate for unfinished quests. Yet the true jolt came from trajectory refinements. 3I/ATLAS's hyperbolic eccentricity of 1.2, calculated from 122 observations across 31 observatories, traced back to the Milky Way's thick disk, a stellar graveyard of giants predating our sun by half the galaxy's age. If accurate, this wanderer predates Sol's nebular collapse, its ices frozen in an era when the universe was young and wild. Speculative models grounded in simulations from Caltech's Zwicky Transient Facility proposed a close stellar flyby as a Victor, flinging it into the void at 26 kilometers per second, relative to the local standard of rest. The human element pierced through. SETI's Allen telescope array, scanning passively, detected no anomalous signals, no engineered hum, yet the silence amplified the poetry, a reminder that nature's engineering rivals our own. As tails lengthened to 50 arc minutes, amateur images flooded databases, their ethereal blues and greens a canvas for collective wonder, binding solitary stargazers in shared vigil. In the arc of its passage, 3I/ATLAS wove a tapestry of contrasts, each thread deepening the enigma of our cosmic neighborhood. Unlike Oumuamua's tumbleweed spin or Borisov's gassy effervescence, this comet's activity ramped gradually, its coma expanding from 5 to 15 arc seconds between July and September, per Lowell's archives. A measured awakening driven by solar flux penetrating its porous crust. Ground-based photometry from Palomar pegged its absolute magnitude at 15.2, dim by daylight standards but a beacon for infrared sleuths. Its dust phase function suggesting forward-scattering grains evolved for light trapping in dimmer climes. Emotional rhythms ebbed here, into reflective calm. Researchers pored over spectra in dimly lit offices, tracing OCS lines to hypothetical sulfurous atmospheres around rogue planets, evoking a quiet hope for hidden habitability. Yet urgency resurfaced as JWST's instruments, from 500 million kilometers out, nabbed particle bursts on October 10th, high-velocity ejecta-rich in silicates, hinting at a crust thinned by eons of micrometeorite sandblasting. It's shedding its history, an ESA spectroscopist noted, her words heavy with the impermanence of all things. Cliffhangers mounted. Would perihelion's heat, peaking at 1000 Kelvin on the day side, trigger a surge or cascade into fragmentation? Simulations from the Planetary Society, using orbital elements refined to 0.01 arc-second precision, forecasted a 20% chance of survival intact, the rest a debris train fading into solar wind. As October 20th dawned, SOHO's coronagraphs framed the approach. The comet's head a fuzzy pearl against the sun's corona, its tail bifurcating into ion and dust streams, a visual symphony that moved observers to silence. In these moments, science transcended data. It became elegy, a meditation on transience amid infinity. Climax gripped the astronomical world on October 20th, 2025, as 3I/ATLAS hurtled through perihelion at 0.25 astronomical units, 37 million miles from the sun, its velocity cresting 68 kilometers per second in a gravitational crescendo. SOHO's LASCO C3 imager, veteran of countless sungrazers, chronicled the plunge. A nucleus aglow, outgassing spiking to 10 to the 28th molecules per second, predominantly CO2 with water's secondary psi. No disintegration marred the show. Unlike its sun-grazing cousins, 3I/ATLAS endured, its tail elongating to 2 degrees, a feathery arc visible faintly from southern latitudes through binoculars. NASA's Goddard team, fusing real-time feeds, reported thermal equilibrium at 300 Kelvin on the night side, warm enough for clathrate ices to vent, releasing trapped volatiles in plumes that danced with solar magnetic fields. The reveal stunned. Embedded in NIRSpec's follow-up prismatic scan, beamed back via Webb's opportunistic slew on October 18th, lay isotopic ratios, deuterium to hydrogen at 1.5 times terrestrial norms, mirroring Enceladus's plumes, suggesting aqueous processing in a parent body with subsurface oceans. Preliminary evidence for cryovolcanism abroad, the bulletin read, igniting fevered debate. Emotional peaks crashed like waves. In packed webinars, jaws dropped at the spectra's elegance. Tears flowed as implications sank in. Water, that universal solvent, sculpted not just here but everywhere, a cosmic recipe for resilience. Yet the intensity tempered into urgent reflection. With outbound velocity locked, observation windows narrowed to weeks. Mars Express's parting shots on October 25th captured sodium tails twisting in Martian gravity, a final gift, grains potentially impacting the atmosphere, seeding trace chemistry for rovers to one day sniff. The comet's arc, now outbound, traced a hyperbolic farewell, its light fading from magnitude 10 to 15 by November, a poignant dimming that mirrored the ache of parting. As 3I/ATLAS recedes into the outer solar system, hurtling toward the heliopause at 26 kilometers per second, its legacy settles like interstellar dust on our collective imagination, a mosaic of molecules that reframes isolation as interconnection. Webb's infrared portraits, archived in NASA's exoplanet vaults, will fuel models for decades. CO2-rich comets as sentinels of radiation-hardened disks, water grains as harbingers of hydrated worlds. Cross-analysis with Oumuamua's non-detection of gases and Borisov's COXS reveals a spectrum of origins, from inter-system ejections to outer cloud flotsam, broadening the catalog of possible chemistries. Ground truths emerge too. Amateur contributions to the Minor Planet Center, exceeding 500 images by October's end. Refined ephemerides to centimeter precision, democratizing discovery in a surge of communal passion. Reflective pauses abound. In quiet observatories, scientists ponder the odds, 1 in a quadrillion for such alignments, yet find solace in the pattern, a universe generous with its messengers. No threats linger. 3I/ATLAS poses none, its path whisking it harmlessly outward. Instead, it bestows empowerment. Tools like Atlas and Rubin, poised to net dozens more by 2030, promise a golden age of interstellar sampling. The emotional arc crests here, in gratitude, for the telescope that saw deeper, for the comet that shared its silence, for the stars that remind us our story is but one verse in an endless symphony. And so, as the last photons from 3I/ATLAS kiss Earth's detectors, we stand at a threshold, compelled not to fear the void but to chase it. What other wanderers await, bearing blueprints from unseen cradles? Will the next, perhaps 4I, glimpsed by Vera Rubin in 2027, carry the spark of unfamiliar biology or echoes of atmospheres we dream to breathe? These questions aren't endpoints. They're invitations to engage, to peer through your own lens, whether a backyard scope or a shared screen. Dive into the data at NASA's archives. Contribute your gaze to citizen surveys. Let this comet's light ignite your curiosity. Subscribe to the feeds of discovery. Comment your wonders below. Share the awe with a friend under the same sky. In doing so, we weave ourselves into the cosmos, not as passive observers, but as active threads in its unfolding tale. What will you see when you look up next? Information updated as of October 20th, 2025.